Hey guys, this is going to be the video on molarity. It should be the second video in the 14.2 section for chemistry class. So molarity is the amount of moles in a liter of solution. So this is moles of solute per 1 liter of solution. So our equation is going to look like this. Molarity is shortened to a capital M. Alright, so it'll be capital M equals moles of solute divided by liters of solution. Alright, and that's going to be measured in molar. Alright, so 1 molar is 1 mole of solute divided by 1 liter of solution. That's laid out in the slides as well if you're having a hard time reading that. I didn't want to write too big. We're going to do number 17 on page 483 together. Alright. That question reads, calculate the molarity of 1.60 liters of a solution containing 1.55 grams of dissolved potassium bromate, KBr. Alright, so this is one where we're going to have to use our molar mass. I already figured out the molar mass of potassium bromate for us so that I don't have to do that later. And we're going to go ahead and start plugging some things into our molarity equation after we figure out how many moles of potassium bromate there are. So we're starting with 1.55 grams. And then we're going to use this molar mass here. So we're going to make it so that grams is on the bottom so it cancels out. So I'm actually flipping this over. So grams potassium bromate cancels, leaving this with moles of potassium bromate. If you do this on your calculator, you get a really small number. 0.013114, and it keeps going, all right? Just leave that in your calculator. You don't have to write the whole number down. You guys know the drill. We're going to take this number, because that's the moles of potassium bromate, and we're going to put it down here. So molarity equals that number. So moles KBr, because that's our solute. So I'm just leaving this number on my calculator. I'm going to put divided by liters of solution. And the book tells us that there are 1.60 liters of solution. Right? It's probably a solution of KBr in water. Alright? So hit pause on the video, try this out for yourself, and then try to write this number in significant figures as well. You're probably going to have to use scientific notation because it is a small number. Because this number is small, and it's being divided by a big number. Alright, so I got 8.20 times 10 to the negative third. When I did that. Alright, and your units are going to be molar, capital M. You may also see this as molar KBr. It just depends on the notation style of whatever you're reading, and that can even change from scientific journal to scientific journal. So don't put too much weight on it. As long as you get this part, you're good for me. Alright? The next thing I want to talk about is preparing a molar solution from a given amount of molar solution. And this is called the dilution of molar. And it is just a ratio. Right? And that ratio is M1 V1 equals M2 V2. All right, so obviously the 1s are what you're starting with, 2 is what you're working towards, M is the molarity of the actual source or stock solution. V is the volume of stock solution. M2 is the molarity of your diluted solution. So this is what like your finished product is. And the volume is 2 is the volume of that dilute solution. All right, so stock solution is usually going to be a much greater concentration than what you really need, because that gives us a way to ship those chemicals without having to pay for all the extra water that's needed. So instead of like shipping 1,000 gallons of 1 molar solution, we can just ship a smaller quantity of like 12 or 18 molar solution and give the same amount of chemicals, and then you can just add the water back to it to get your desired solution. So if you go to page 486 in your textbook, we're going to pick up with number 24. 24 reads, what volume of a 3.00 molar potassium iodide stock solution would you use to make a 0.300 liter of a 1.25 molar potassium iodide solution? So let's make sure we're getting our units straight and attaching them to the correct part here. So what we're starting with is so it says what volume of a 3 molar potassium iodide. So that's what we're starting with, this 3 molar potassium iodide, and we're solving for volume 1, because it asks how much of it are we going to use. So the other 2 values go on the other side of the equation. So our molarity is 1.25 molar. That's our desired concentration. And our volume we need is only 0.300 liters. All right, so as you can see, this is some pretty easy algebra, right? We're just solving for this value, so we divide both sides by 3.00 molar. Molar cancels. All right, hit pause on your video. Try this out for yourself. Make sure that you can get an answer on your calculator. Try to write it in significant figures. I wrote them as they are in the book. So 3 sig figs, 3 sig figs, 3 sig figs. Your answer should be in 3 sig figs. All right. If you did all this, because of the way these interact, it's just 125 liters. Or I'm sorry, milliliters, because that's not liters. Like I said earlier, get your units right. Okay. Molality is a little different. I'm going to talk about that in the next video. Once again, I'm leaving a bunch of practice problems unsolved in the textbook. Use those. Practice them. Give them a shot. The answers to some of those are in the back of the book. Worked out as well. If you want to, you can also work these out, take a picture of them and send them to me. I will give you answers. Send me questions. Send me anything that you need. All right, I will help you as much as I can. Have a good day, guys.